In today's lesson, we're going to combine your two favorite things, geometry and probability. Come on, you know it's true. All right, here we go. We're going to find the probability that an object that lands in the larger region will also land in the inner shape. So imagine that you have a box that is 8 by 6, and inside, it's kind of like an open topped box, and you're going to flip a coin into it. And then you also have inside that box, a rectangle that's 4 by 3, and we want to know, if that coin is going to land somewhere in this rectangle, what's the probability it'll land in the smaller rectangle? So what's the probability it'll land in this small rectangle if we know it's going to land in the big rectangle? So what we'll do is, quite simply, the area of the small rectangle divided by the area of the large rectangle. The small rectangle, the base times the height would be 4 times 3. And the large rectangle, the base times the height would be 8 times 6. So we got a probability of 12 out of 48, or 1/4. So 1 out of every 4 times you throw a dart at this board, assuming you're going to hit it every single time, the dart will land in that square, kind of. Notice too, we could have just simplified up here. We could have said, look, 1 goes into 8, or 4 goes into 8 twice, and 3 goes into 6 twice. So what's 2 times 2? That's 4, and all you have left on top is 1. So there is another way to do it. Moving on, same thing. Given that an object is going to land in the big square here, what's the probability that it'll land in this triangle? Well, to find that probability, we'll do the area of the triangle divided by the area of the square. The triangle, we're going to do 1/2 base times height. The base and the height are 8 and 6. And for the area of the square, we'll just do 10 squared, or 10 times 10. So 1/2 of 48 is 24, and 10 times 10 is 100. We can simplify that fraction and make it 6 out of 25. 6 out of every 25 times an object lands in this box, it'll land in that triangle. When you take aiming into effect, that might change things, but if you're just kind of randomly flipping a coin or dropping a ball in there, it'll land on the triangle 6 out of every 25 times, or 0.24 times, or 24% of the time, however you want to look at it. Okay, same thing here. We're trying to find the probability that it'll land in this 10 by 10 square, given that it's going to land in the 14 by 14 square. So we'll do the area of the smaller one divided by the area of the larger. So we got 10 times 10, and we got 14 times 14. It's 100 over 196. And we can simplify that fraction. And we'll make it, they're both divisible by 4, so how about 25 over 49? 25 out of every 49 times you flip a coin into this 14 by 14 square, it'll land in the red square. Hopefully you're seeing the pattern. Same thing here in number 5, just because it's circles, it's not going to change anything. We're trying to find the probability that we throw an object into the big circle and it lands in the blue circle there, the smaller one. They give us the radius of the larger, they give us the radius of the smaller. They're telling us to leave pi as pi, which is really going to make a lot of sense. You'll see here why in just a second. So we'll do the area of the smaller circle over the area of the larger circle. That'll be the probability. Pi r squared for a circle. The smaller circle's got a radius of 6, so pi times 6 squared. The larger circle's got an area of 10, so pi times 10 squared. So the area of the smaller circle is 36 pi, and the area of the larger circle is 100 pi. So if we're going to simplify this, first of all, notice that pi over pi is 1. Just cancels out. So there's our probability right there, 36 out of 100. So you could say 36%, or 0.36, or we can simplify this fraction and make it 9 out of 25. All right, right, one more. Which is greater, the probability that an object lands in the square or the probability that an object lands in the circle outside the square? So probability that it lands in the square or the probability that it lands outside that square, which is greater? Okay, well, the probability that it lands in the square, well, how about we just figure out the area of the square? 10 squared, 100. Then let's figure out the area of the circle, which is pi r squared. So pi times 10 squared. Radius is 10 if the diameter is 20. So it'd be 100 pi. We'll go ahead and round that. 314. So the probability that it lands in the square, given that it's going to land in the circle, would be 100 out of 314. But they want to know if that's greater or less than the probability that it's going to land in the area outside the square. Well, we haven't even figured out the area outside the square yet. That's this blue area here. So we know the whole circle is 314. So we're going to figure out the area of the space outside the square. The area of the whole circle is about 314. And we know the area of this square is 100, so the area outside the square would be 314 minus 100, or 214. So the probability that an object thrown in here will land in the square is 100 out of 314. The probability that it would land in the space outside the square, which by the way is the complement of that, is 214 out of 314. So which one's greater? Obviously, the probability that it'll land outside the square is greater, because it's 214 out of 314 is greater than 100 out of 314. Really, we didn't even need to write these two probabilities. As soon as we got the area was 100 for the square and the area was 214 for the space outside the square, we could have given this answer, that the probability is greater than an object will land in the space outside the square. Probability is greater. This should say that the object will land in the area outside the square. Okay, so we definitely have to be good at finding area of two-dimensional shapes. And then once that's the case, it's really not all that much more. Just throwing a little bit of probability into it. That's all I've got for you today, and we'll see you tomorrow.